All right, relations and functions is our title. A relation is a pairing of x's, or x's are like the domain or the independent variable, and the y's, or the range. So, a couple of ways that we can represent a relation. We can have a mapping. So we just got like this circle represents the domain or the x's, and then the second circle represents the y's or the range. And so if they're paired together in any fashion, like so, then this would be called a relation. We could also write it in sort of a set builder, in a set notation. So we could write the ordered pair 1, 8. If you remember back, the first number in an ordered pair is always an x, and the second number is always the y in an ordered pair. So 1, 8, 2, 0, according to our circles of our mapping, and 4, 3. So that's a relation anytime we pair them up. All right, a function is a special type of relation where each x in the domain is paired exactly with one unique y in the range. So here we have 3 different examples. Okay, and we're going to go through and decide which ones are functions and which ones are not. So let's look at letter A. So if you look at the first circle here, get a different color. So if I were to look at the 1, for example, 1 only gets paired up with -2. Okay. If we were to look at the next one, 4 is only paired with the 3. And then 8 here is paired with the 5. Oh, and we do have another circle there, don't we? Another line. And then 1 is also paired with 5. So you'll notice that 1 has 2 partners. 1 is paired with -2, and it's also paired with 5. So this is not a function. Not a function. 1 has 2 partners. All right, let's look at letter B. This time 1 is paired with a 3. What color did I use? Okay. 4. And then 8. So every single x is only paired with one y. So this one is a function. That one's a function. All right, let's look at C. C is kind of interesting. So pause the video and decide what you think about it, whether or not it's a function. All right, welcome back. So 1 is paired with -2. 4 this time is paired with -2. So 1 and 4 both are paired with -2. And then lastly, this 8 here is paired with 5. So now we have to decide, is it a function? Does every x from the x perspective, does every x in the domain or the first circle get paired with 1 in the range? Yeah, it does. This is, in fact, a function. Even though -2 over here is paired up with 2 different, even though this -2 is paired up with 1 and 4, it's always from the perspective of the x. So if I were to look at the perspective of 1, 1 is only paired up with -2. Okay, now think about these as people. 1 is only paired up, like Bob is only paired up with Sue. Okay, according to Bob, Bob only has 1 girlfriend. Okay, what have you. The 4. Okay, so if this is, I don't know, Jack or something, Jack's also with Sue. But according to Jack, he only has 1 girlfriend. So this is, in fact, considered a function. All right, now there is a distinction between B and C. They're both functions. However, if you notice in B, every single x has one y, and also every y has one x. So not only is this a function, but it's also considered a one-to-one function. It's kind of like a monogamous relationship. Okay? All right. If you have questions about it, come see me in person, okay? All right, let's look at some graphs and determine whether or not it's a function or not. If we want to determine if it's a function and we're given a graph, again, definition-wise, a function for every x, so every x would be the horizontal. For every x value, there's only one y value. Okay, so one way that we can do that is there's something that's called a vertical line test. And you might remember this from Algebra 2. If not, it's okay. But what that says is that if we were to take a graph and we were to draw a vertical line anywhere on this graph, it only can hit one place because at this particular x value, it only hits the graph in one y value. Okay, no matter where we were to draw it. So like if we drew it here, or maybe we drew the dotted line here, it only hits the graph in one spot. So this one is, yes, it's a function. Look at number 2, though, over here on the right-hand side. If we were to drop a vertical line here, well, it kind of looks like it would pass, right? It hits it right there. But if we were to drop it, say, here, now we've got 2 points of intersection, so no function. This one's not a function. Vertical line test. So if you were taking notes, which you should be, probably in that left-hand column would be a great place to write vertical line test. Tells me if it's a function or not, and then write in words what that is. Okay, you can only hit it in one place. Okay, we want to talk about domain and range to pull it off of the actual graph. We talked about that if it was in a mapping or an ordered pair set notation. But if it's on a graph and they're asking for the domain, remember that the domain are the x's. All right, so for this first one on the left, let me number these so we can talk about them. The domain. Now, if you were to take, let's say, this line, and I want you to imagine put your pencil up here on your and kind of follow this line. And if we were to, sorry, I got something that popped up here on my screen. If we were to take this red line and we were to move it across towards the right, okay, would it hit the graph? When would it start to hit the graph? Now keep in mind that this line, these arrows here, mean that this line continues forever and ever and ever and ever. And this red line, we're not putting any limitations on it either. And so it can go, right? What if I move the line to the left? Would it still hit the line if we extend both? Absolutely. So in fact, this line is going to hit in every single x value. So our domain would be all real numbers. And the way that we would write that is, oops. Now there's some notation there. This says that x is in the set of real numbers. If you don't like that, you can just leave off and just say all reals in words. Okay. The range, which is the y's. Right? Let me go ahead and the range of this graph are the y's. Alright, so now if I were to take that red line and now we're going to kind of, no, this is not the vertical line test, but if I were to take this red line, now put your pencil where this red line is and move it that way, move it up, when is it going to hit the graph? Everywhere, right? If it's here at negative, I don't know, 1, 2, 3, When y is like -7, it's going to hit the graph over here. If I move this down, it's going to hit the graph way down here below. If I move it up, it's going to continue to hit the graph, right? No matter where I put it. Remember that I can extend these lines however long I need to. So the range is also all reals. So you can write all reals, or you can say y is in the set of all real numbers. All right, typically they'll just use the double back R. That means real numbers. Number 2, domain and range. All the x values. So again, if I were to think about this red line here, and I move it that way, when's it going to hit it? Remember, I can extend this out, right? It's going to hit it way up here, maybe. Right? So all real numbers, or you can write all reals. The range, the y values. You might need to pause. I'm trying to cut back on some of this time here. But the range, it's not going, if I drew the line in here, whoops, if I drew the line in here, we don't hit the graph yet. When do we hit the graph? Not until we get right there, right? If I move that up, so that's at 1, 2, when y is at -3. So it's going to go from -3 to forever. Yeah, I don't need that. So we can say whenever y is greater or equal to -3. Okay.